This is a Unit 15 seminar on trigonometric transformations. So I'm going to go through quickly the very basics as well as the 5 key points of the sine curve and the cosine curve. And then we're going to analyze some mapping relationships. So everything you did in Unit 10 and 11 with functions, transformation tables, mapping relationships are now going to be applied to trigonometric functions. But the little bit of difficulty is that we're going to toss some word problems in there too. And there's definitely going to be one on the final exam. There are going to be word problems on your 14 and 15 tests, so you need to know what you're doing. Now, the way we derive the sine curve and the cosine curve is by taking points on the unit circle. And you have learned the special triangles, the 30, 45, and 60-degree special triangles. Really, we can make triangles for every single degree measure on the unit circle. And by getting the sine points, which usually correspond to your y-coordinates of your special triangles, and the cosine points, which correspond to the x-coordinates of your special triangles along the unit circle, we can derive the sine and cosine curve. So, for example, if I plotted all those y-coordinates together, I would get the sine curve, which looks something like this, which you don't have to put in your notes, but what I do want you to jot down are the 5 key points of the sine curve, because the 5 key points are what you're going to apply your transformations to. So, first point would be 0, 0. The second key point would be pi over 2 and 1. Third key point is pi 0. Fourth key point, 3 pi over 2 negative 1. And the final key point is 2 pi 0. Okay, so that corresponds to, remember, the x is equal to 0. Y is equal to 0, which is my x-axis. Also is the axis of symmetry. That's very important because your starting point always is asked for the original parent function is at the axis of symmetry. That is a key component that is going to come into play when we do word problems, because when we're trying to figure out phase shifts, you have to identify where the graph intersects your equation of the axis of symmetry, or where the graph intersects the axis of symmetry, okay? Once we have our axis of symmetry, then we look at our maximum point, then back to the axis of symmetry, then our minimum point back to the axis of symmetry. In order to complete a full cycle, or one period of your sine function, you need these 5 key points. The cosine function looks a little bit different, but also we have 5 key points. So instead of starting at my axis of symmetry, I start at my maximum, go to my axis of symmetry, go to my minimum, back to my axis of symmetry, and finally at my maximum again. So my key points for my cosine curve, we start at 1, 0. The second point is going to be pi over 2, 0. Then I have pi, negative 1. Then 3 pi over 2, 0. And 2 pi, 1. Notice that the x-coordinates are still the same for the key points, but the corresponding y values are different. And again, I do have my axis of symmetry. The x-axis, y is equal to 0. Now, we talked about this a little at the last seminar. What would happen if I took my marker and I covered a portion of the curve? So if we look at the other graph, I have my sine function starting and then going to my maximum point. So what if I just colored in, ignored that part, and ignored all of this? What does that graph now look like? What does the graph look like? Starting at the equation of axis, what does this portion of the graph look like? I'm going to highlight it. What does that look like? Yeah? It looks exactly like the sine curve, because really the cosine curve is just the sine curve with a shift of 90 degrees. It's just been shifted 90 degrees. So there's a relationship between those two curves. Now, in order to be able to fill out your transformation tables and apply the proper mapping relationships, you need to be able to analyze equations, trigonometric equations. So I'm going to start off with a cosine equation, because I know Unit 14 we deal with a lot of sine functions. And we're going to analyze the amplitude, period, phase shift, and vertical translation based on this equation. Y is equal to 1/2 cosine x plus pi over 3 minus 3 over 2. Now your very first step is to look at the phase shift portion, the bracket portion of your equation, and make sure there is nothing in front of your x term that needs to be factored out, because if there was a number in front of my x term, then that would be a horizontal stretch or horizontal compression that I would have to make sure has been factored out. We're going to do that for the next question. Right now, x is, there's no number in front of x, so I can analyze this equation. So the 1/2 in front of my cosine function, what does this represent? My a term. What does it represent when it comes to transformations? A vertical? Vertical shift is going to be over here. So this is going to be a vertical compression by 1/2. We have a vertical shift by -3 over 2 units down. Remember, you have to tell me the direction. If we are going to translate this into a mapping relationship, this means that I have to multiply my y coordinates by 1/2, and I have to subtract 3 over 2 from my y coordinates. Mapping relationship. Now, this portion gives me my mapping relationship in regards to my x coordinates. So do I have to multiply or divide my x coordinates by anything? No, because I don't have a horizontal compression or a horizontal stretch. But I do have to, this is a phase shift left by pi over 3, so I have to take x and subtract pi over 3 units from my x. And that is your mapping relationship, which you would then apply to your 5 key points in order to get new x and y coordinates in a transformation table. Now let's analyze the amplitude first of all. Now in a word problem, or if you were not given the equation, you were asked to come up with the equation, your amplitude is your maximum, or do you guys remember the formula for amplitude? Yep. Very good. Max minus min divided by 2. However, when you're given your equation, your amplitude corresponds to your a term, the vertical stretch or your vertical compression. So in this case, we have a vertical compression of 1/2. So my amplitude is, everything is going to be compressed vertically. That means that, let's see. Now, very important to realize that this is not the same as your period. Remember, my formula for period is 2 pi over k, where k is your horizontal stretch and horizontal compression term. Since there is no k here, there is no horizontal stretch or horizontal compression, k is equal to 1. Therefore, my period is still 2 pi. Now, people confuse this often, and they think, oh, vertical compression means that the graph is going to be squished. That means my period is going to change. No, vertical compression is like if I had a beach ball on this desk and I was compressing it vertically. It's a vertical force like this, right? That is not the same as a horizontal compression, which would actually affect my period. Vertical compression only affects your y coordinates, has nothing to do with your period. Period is affected by your x. Finally, I have my phase shift. So phase shift is my horizontal transformation. So phase shift is going to be left by pi over 3. And your vertical transformation vertical shift is going to be down by -3 over 2 units. Okay. So that is all the information that we were able to extract from that one equation. That was a little bit more simple because we didn't have to factor anything out. Now I'm going to do another example with you. So y is equal to 3 sine 2x minus 3 pi over 4 plus 3. First thing we have to realize, some students will look at this and just say, oh, to the right by 3 pi over 4 units. However, because there is a term in front of my x, we have to work with this a little bit. I think I want to... Let's do this. Delete. I do not want to clone it. I want to... There we go. Okay, so first of all, on the side, I know 2x divided by 2 is going to give me 1x, but I have to figure out what 3 pi over 4 divided by 2 over 1 is. Okay, first step, we've got to do that. So that's going to be 3 pi over 4 multiplied by 1/2, which is going to give you an answer of 3 pi over 8. Okay, so I can rewrite this equation as y is equal to 3, then I have my positive 3 at the end, and then I can write it as sine take the 2 out and left with x minus 3 pi over 8. So that's the true equation. And remember that this term, which also represents a horizontal compression, is your k term. So when you're analyzing this, we'll start with the period. Because my graph is going to be horizontally compressed, period formula is 2 pi over k. That means 2 pi over 2 divided by 2, which is going to give me 1 pi. So what used to take me from 0 to 2 pi to complete one cycle, it's going to take you from 0 to pi. So the graph is going to be squished horizontally, okay? It's going to be compressed horizontally. Vertical stretch by 3 means that my amplitude is equal to 3. And finally, my phase shift is not by 3 over 4. Your phase shift is actually, in the direction right by 3 pi over 8 units. And your vertical shift is going to be 3 units up. Okay, does everyone understand that? Yep. Radians to degrees, it really doesn't matter. Both are accurate. So a lot of the test questions are going to do with real life problems which don't correspond to radians. They actually correspond to real numbers. So I'm going to show you now with the word problems how we would tackle that. But either, it doesn't really matter what you use, okay? Both are right. So now let's tackle the word problems. Okay, so actually, we'll just look at a few graphs. This, for example, has no vertical stretch or vertical compression, but it's a horizontal shift up by 1. So my x-coordinates are exactly the same, but my y-coordinates have been shifted up by 1. So a very simple, straightforward mapping relationship. X-coordinates are the same. Y-coordinates get shifted up by 1. That's all that means. For this particular graph, I have a vertical compression by 0.5. So my x-coordinates stay the same. However, my x-coordinates have to be divided by 2 because I have a horizontal compression there. And my y-coordinates get multiplied by 1/2. And there's no vertical shift for that particular one. The one on the bottom, I would have the exact same situation for my x-coordinates, but now my y-coordinates get multiplied by 1/2, and on top of that, I have to subtract 1/2 because I have the vertical translation happening. Okay, so mapping relationships and how they correspond to the graphs. Okay, so we have a good 20 minutes for word problems. Okay, so the diameter of the car. I'm going to come back to this slide so you can copy it. Right now, I just want you to drop your pencils and understand, okay, for these word problems, because this is straight from your unit guide. You need to understand what I'm doing. So, first of all, the diameter of a car is 52 centimeters. While the car is being driven, the tire picks up a nail. Draw a graph, and we have to also kind of come up with a graph that's going to help us explain all this criteria. So what people really struggle with is how to draw the graph, okay? First, we're just going to draw a graph for the situation and analyze the questions. Then I'm going to give you a situation where I'm drawing the graph and coming up with a transformation equation that describes the graph, okay? If we look at our original sine function, so I'm going to go back for a second. Okay, I don't want the ugly one. For both the sine and the cosine function, even though we have 5 key points, look at how many parts we divide our graph in. So from my minimum to my maximum, that's going to be part of my first section of my graph. From the minimum back to my axis of symmetry, that's the second portion of my graph. from the axis of symmetry back to my, sorry, that was a maximum, this is my minimum, is the third part of the graph, and from my minimum back to the axis of symmetry is the fourth portion of the graph. So every sine curve and cosine curve is divided into 4 key parts, okay? That is essential to understand in order to figure out the word problem. So let's quickly go into this. Okay, back. Okay, so we're going to figure out the period and the equation of the axis before I actually draw my graph. All I know is that the diameter is 52 centimeters. Now, that means that the graph is going to go from 0 to 52, right? So if I have my equation of the axis, that is the same as 52, my maximum, subtract my minimum, divided by 2, which is going to give me 26 centimeters. 26 centimeters. 26 centimeters and the equation of the axis also represents the radius. This is very, very important because, and you guys can take notes, more when we draw the graph, then you stop what you're doing and just look at it, okay? Most of the word problems you're going to encounter have to do with wheels and circular objects like this tire, so radius comes into play a lot. It also, the equation of the axis is the same as my amplitude formula because my amplitude is going to be maximum plus my minimum divided by 2. Oh wait, hold on. You're opposite. This should be plus, this should be minus. 52 minus 0 divided by 2. In both cases, we have 26 centimeters. So my axis and my amplitude both are 26 centimeters. Period is a little bit more complicated. My period is going to be the circumference of a circle, which is 2 pi r. Whenever we're dealing with circular objects, the period is the circumference. And I know that I have 2 pi multiplied by my radius of 26 will give me 163.4 centimeters. That is my period, 163.4 centimeters. So I know a full one cycle is going to take me 163.4 centimeters for this nail to complete one full rotation. Now, how do I actually figure out how to get I'm going to use the period information to figure out what my x-coordinates are going to be. Because if we look at the graph, and this is where I want you to pay attention, I've put my axis, which is right about at 26 centimeters. I'm starting at 0. So basically, I know generally that I'm going to go from I have to plot out my 5 key points. So I'm going to go from my minimum to my equation of my axis to my maximum, which is 52, right? Back towards my minimum, my equation of my axis. So we go from the minimum, equation of the axis, to your maximum, to the equation of the axis, back to your minimum, and back to the equation of the axis for one complete cycle, right? So I'm going to draw that right now, connect the lines. But the problem is I have no idea. First of all, it doesn't look like a sine curve. It doesn't look like a cosine curve. And I don't have any idea what my x-coordinates are. Well, the is going to correspond to one x-coordinate. This is going to correspond to another. This is going to correspond to another. This is going to correspond, and this is going to correspond. Now, this is where I make my discovery. I know that 100 and my period, which is 163.4, has to be divided into 4 key parts of the graph, right? So divided by 4 is going to give me about 40.85. So first x-coordinate is going to be 0, obviously. Then this is 40.85. If I add to that another 40.85, I get 81.7. Then I get 122.55. Then, and so on and so forth, like 163.4. So sorry, from this cycle all the way to here would be one complete cycle from this, right, all the way down here. I didn't have to actually draw this part. Now, if I wanted to, so I know already, if I wanted to make an equation for this, y is equal to, what is my amplitude? Amplitude, 20, 26. And if I want to make this a sine curve, right? Your equation of your axis always corresponds to your vertical translation. So I have, my equation of the axis is 26, so my vertical translation is up by 26, because the original graph, it starts at 0, 0, but our equation of the axis is 26. Now, if I cover this part, right, and continue the curve, it's going to look like a sine curve. So that means if the original point of the equation of the axis is here, my graph has actually been shifted, right? This part is going to be your horizontal transformation. Always locate the first point of your equation of the axis, and my horizontal translation has actually been shifted by 40.85. 40.85. So in that, my graph is going to be t minus 0.85. Oh, sorry, 40.85. And that's how I actually come up with the equation of this particular scenario. And that's how you draw the graph. I could continue drawing. If it says to draw the graph for 2 complete cycles, I would continue drawing the graph. This is a little bit harder because the values are decimals. I'm going to do another example for you that's straight from the unit guide. But for now, let's just answer the questions based on the graph. How high above the ground will the nail be after the car has traveled 0.1 kilometers? Now, first of all, this whole situation has been in centimeters. So we have to convert 0.1 kilometers is the same as 10,000 centimeters. So if we take 10,000 and divide it, it says how high above the ground will the nail be after the car has traveled that many centimeters. We take our period. We always divide by our period, which in this case is 163.4, to get a value of 61.2. This tells us how many cycles. This is for one cycle. I have 160.4 centimeters. So for 61.2 full cycles can be traveled in 0.1 kilometers or 10,000 centimeters. Okay. To save some time, I want to go on to the next question, which again you don't have to copy down. Just make a note that this is page 388. number 12 in your unit guide. I'm not sure if it's a 14 guide or a 15 guide, but it's one of those questions students had a lot of difficulty with. Yep. That's how many, after 10,000 kilometers, how many cycles the wheel has traveled, that nail has traveled. If that nail is marking 163.4 is one complete cycle, then how many cycles gets traveled in that distance?
So was the question asked how high above the ground?
Oh no, it just said the nail is this much. Yeah, okay. So the water depth in a harbor is 21 meters at high tide and 11 meters at low tide. So right away we know our maximum and our minimum points. One cycle is completed approximately every 12 hours. That means we know our period this time, okay? So we have about 10 minutes. We're going to calculate an actual equation and draw out the graph for this particular scenario, which is an important question, okay? So again, my amplitude is equal to my max minus my min divided by 2. So if I take 21 minus 11 and divide it by 2, I get 5. Now the equation of your axis, which also corresponds to my vertical shift, because if my axis of symmetry is originally at 0, y is equal to 0, whatever my equation of axis is now, if it's down, negative, or positive up, it is going to be the new vertical transformation. This is 21 plus 11 divided by 2, which gives me a value of 32 divided by 2, which gives me a value of positive 16. Now, what's different from the last question is I also know my period, so my formula for period is 2 pi over k. I need to have a k term in order to make a proper trigonometric equation. But I don't know what k is, I just know that my period is 12. So you don't let your k term be 12, you let your period be 12, and you solve for k. So if I cross multiply here, I know that 12k is going to be equal to 2 pi. So that means that k is going to be equal to 2 pi divided by 12, or we can simplify that to pi over 6. Does everyone understand those components of the graph? So even before I draw anything, I figured out my amplitude, my equation of the axis, which is also my vertical shift, and my k term. Okay, so let me fill in. So really all that's left is my horizontal shift, which I'm not going to be able to figure out unless I draw out my graph. You won't be able to know unless you draw out your graph, okay? So originally, right now I have y is equal to 5 sine. I also know that my k term is pi over 6. I'm looking for my shift. I know my variable is time. And I know finally my vertical transformation is positive 16. Okay, so even though this is my equation of my axis, we'll make this my equation of my axis, and the actual graph is going to start here. Okay, so my equation of my axis is at 16. Is that what we said? 16? Yes, 16. My maximum is at 21. My minimum, we said, is at 11, right? So this is not to scale, but if we plot out our points, we're going to start at my minimum. I'm going to go over here, then in another 2 I'm going to go to my maximum, back over here, back to my minimum. Okay? That's for one complete cycle. And these are all going to correspond to x coordinates. Now, obviously, it doesn't look like a sine curve yet, but we're going to get to that. Now, what did I say? What is one complete cycle? How much time does it take one complete cycle to be completed? How much time? My period is what? 12 hours, right? So if this is 12 hours, we have to take my period, which is equal to 12, and I'm going to divide it into 4 key parts of the graph. 4 key parts of the graph. That means that every one of those x-coordinates are going to go up by 3 hours. We start at 0 hours, we go to 3 hours, then we go to 4 hours, then we go to 8 hours. Hold on. Sorry. What am I missing? 6. Oops. I can't count today. Okay, that. So it's going to go up by 3 hours every single time. So 3, 6, 9, 12. There we go. So those are your corresponding x-coordinates. 3, 6, 9, 12. Now let's actually connect the dots. So draw the graph. We're not going to stop at 12 hours. We're going to keep going. But for now, all we need to draw is one complete cycle to find out what my horizontal shift is. Now, what is the most important point to locate the horizontal shift? What point am I looking at out of those 5 key points? Does anyone know? Yep. Exactly. The first point on the equation of your axis. Because if I cover everything to the left of this point, this curve all of a sudden looks like a sine curve. So that means that from 0 up to this point, that is my horizontal translation, t minus 3. Which means the graph has been shifted to the right by 3 to make the curve make sense. Okay, so does everyone understand the steps involved to get from the sketched part of your graph to the curve? So I'm just going to repeat the steps again. First, we plotted our maximum, our 5 key points. Really, I started at my equation of the axis by drawing that. Then I start from 0, go to my axis, go to my maximum, back to the equation of the axis, back to my minimum. Then I took my period, divided the period into 4 key components, figured out what my x-coordinates were, connected the line, filled out all the information that I already knew, my amplitude, my k term, my vertical shift, and by drawing the graph, you finally figure out your horizontal compression. Very simple. That same process you apply to any word problem. So the pendulum problem, the tire problem, the tide. Anything, trigonometric functions describe anything that is periodic behavior. That means that it's a pattern. It keeps repeating in the same exact pattern. Nothing changes to it, okay?